Okay, so we're going to talk about bonds and molecules. Okay, so let's take a molecule. We'll do water. Okay, so between oxygen and hydrogen, each of these on the periodic table, probably on the back of the one that they've distributed to you guys, it'll tell you that each molecule, or sorry, each atom by itself has a certain electronegativity, right? Mm-hmm. And if these electronegativities are different, then they are polar, right? Because if the charge is different, like let's say there's a electronegativity of 2 and electronegativity of 5 on this side, right? And there's a bond between these two. This is a polar bond because these charges don't match. They're not symmetrical. So these two are polar. It's a polar bond. Basically because they're different atoms. But the electronegativity is different. That's what we're looking at when we're talking about them being polar or not. The bond. But when we're talking about a molecule, let's see a good example. Okay. So we have CO2. Okay. We'll just do CO2 for now. CO2, does anyone want to take a stab at that? Is it polar or nonpolar?
It's non-polar.
It's nonpolar. Why?
Because both the polarities point out towards the oxygens, canceling each other out, so the net polarity is 0.
Yeah. In other words, if we were to cut it in half, right? Is it symmetrical? Nonpolar. Cool. What if we had, do you have one example?
Polar or non-polar molecules? Yeah.
So like, I think
CCl4.
CCl4.
Uh-huh.
That one's, I think that's going to be pretty, okay, we'll just do it.
It could be, I'm not sure if it is yet.
What do you guys think?
It's also non-polar.
Yeah.
They're symmetrical.
Mm-hmm.
It does have polar bonds.
Say that again?
It has polar bonds, right?
But the bonds itself, yeah, if we were just to focus on the bond between carbon and chlorine, they would have different electronegativities. Pretty sure that carbon and hydrogen are close in electronegativity. And so in that case, generally we say that it's nonpolar, I think. You don't want to check me on that.
There's a difference of 0.4.
Yeah. I think that's the smallest difference.
Okay.
I'm not sure.
So in this case, there are polar bonds present, but the molecule itself is nonpolar.
Yes. Polar bonds, but the whole thing, yeah, exactly, you said it.